right, AP Stats, we're going to finish this packet. All right, so interpreting box plots. So interpreting box plots basically means the same thing when we're interpreting like other graphs. We're just going to ask questions about them and then use the graph to answer the question. So it's kind of almost like I do now. All right, example 6. Juan's number of rebounds each game. All right, so find the following information. Number 1, what is the median number of rebounds each game? All right, so looking at this box plot, we know that this is the min, this is the max, Q1, Q2, Q3. And remember that Q2 is our median. So all we need to do is look at this line right here, and we know that the number line, I'll go ahead and fill in the empty numbers, just goes by ones. All right, so our median is right at 10. So our median is 10. Be sure to include your unit. 10 what? 10 rebounds. All right. That's a lot of rebounds, actually, now that I'm thinking about it. All right. What is the minimum number of rebounds Juan had in the game? So you just go to your bottom whisker, and your min is 4. 4 rebounds. Man, I want to recruit Juan for Banneker. That's a lot, right? That's good. All right. In 50% of Juan's games, he scored between blank and blank rebounds. All right, so remember, we've got 25% here from the min to the Q1. We have 25% here from Q1 to Q2, 25% between Q2 and Q3, and 25 between Q3 and Q4. All right, so, and I think this question meant to say the middle 50%. Like whenever we're asking about the middle 50%, we're basically asking about the box of the box and whisker, because the middle 50% is here. So between Q1 and Q3, he scored between 8 and 11 rebounds. 8 is our Q1, 11 is our Q3. So the middle 50% of the rebounds he scored, 8 and 11. The first 25%, the lowest 25% would be between 4 and 8, and the highest 25% would be between 11 and 13. All right, are there any outliers? Remember, outliers are designated with a little star. I don't see any, so no outliers. All right. Take a minute, read through the question right here for example 7, see if you can answer it, and we'll come back together. All right, so the box plot suggests that about 50% of high schools have more than what number? So basically, they want to know what the median is, right? Because the median designates the lower 50% from the upper 50%. So if we're cutting this data right in half to have 50% on one side and 50% on the other, they want to know what the median is. All right, so looking at it, our median is right here, which is going to be between 100 and 110. So what's the number right in the middle between those two? It looks like these are going by 5s. So this would be 105 band members. 105 band members would be... What? All right, Mr. Patterson just came in and ruined my video. Okay, where was I before he started unlocking my door without permission and yelling? All right, example 8. I want you to go ahead and pause the video, try and answer this question on your own, and then come back and we'll discuss. Oh, I never even finished writing the word members. All right. All right, the 5-number summary for the number of houseboats on each lake in Minnesota is shown in the following table. The 5-number summary suggests that about 75% of lakes in Minnesota have more than what number of houseboats? All right, so remember, $25, $25, $25, and $25. So if I want more, 75% have more than what number? That would be above the Q1. Remember, the Q1 number is 75% is above, 25, 25, 25. So whatever's above the Q1. So I just need the Q1, which is 18. So 18 houseboats. All right. Pause the video, try example 9 on your own. All right, so the 5-number summary for the number of gym members at each gym in Shanesville is shown in the following table. About what percent of gyms in Shanesville have 56 or fewer gym members? All right, so remember 25, 25, 25, and 25. So 56 is my Q1, right? So what percent of gyms have 56 or fewer? That would be 25%. 25%. All right. All right, now we have a sample free response question here. So this is a type of free response question that you would see on the AP exam. So your AP exam, 50% is multiple choice, 50% is free response. So we need to do these free responses and do well on them. All right, so Catherine and Anna suspect that athletes, students who have been on at least one varsity team, typically have a faster reaction time than other students. To test this theory, they gave an online reflex test to 33 varsity athletes at their school and 29 other students. Here are the parallel box plots and numerical summaries of the data reaction times in milliseconds for the two groups. Write a few sentences comparing the distribution of reaction time. All right, the word comparing. You should automatically think comparing and describing. It's very prescriptive. They want you to say certain things, right? So think about the certain things that we should address. Hint, there's 4 letters that we should address. What are those 4 letters? All right, so we need to address shape, outliers, center, and variability. It doesn't matter to me if you wrote them in a different order. As long as we hit all 4, we're good. All right, so shape. Remember, we can't really say what shapes are with box plots. We can either say they're symmetric or not symmetric. We can look at the outliers, and we can say they're skewed a certain way based on the outliers, because we know that outliers skew the data, right? All right, so looking at these two distributions, it looks like we have 2 outliers right here and another outlier right here. So these 2 box plots are definitely skewed in the direction of the outliers. So we'll say they're skewed right. So the shape of both distributions of reaction times are skewed right because of the outliers. All right, which leads me into O. O stands for outliers. So are there outliers? Yes, there are, and don't forget that we need to actually mention where they are, like what times they would be in each distribution. So go ahead and pause the video and practice writing a sentence. Be sure to include context and mention where the outliers are. Okay, so here's my outlier sentence. I'll read it to you because I'm sure my handwriting is terrible. The distribution of reaction times of other students, and we're talking about the top one, other students, that's not grammatically correct, the distribution has 2 outliers at approximately 430 milliseconds and 475 milliseconds. All I did was draw a line down to kind of see where they hit this x-axis. And again, as long as you say the word approximately, then you're fine. You can say approximately, right? You're guessing about what the value is, but I don't know for sure. All right, and then I have the varsity student distribution has 1 outlier at approximately 395 milliseconds. So that's this one right here. And it doesn't quite hit the 400, so I just got it as close as I could. Approximately 395. All right, what does C stand for? I hope you said center. And what were the 2 statistics that we typically use to measure center? All right, mean and median. So you could write a sentence about either one. It doesn't matter. They give you both in this distribution right here. So whatever you choose, just make sure that you use comparing words. Remember, comparing words are greater than or less than or about the same. So pick either the mean or the median and write your sentence to describe them. I chose the mean, but you could have chose the median, doesn't matter. I said the mean reaction time of the varsity students, which this athlete right here, of 270.1 milliseconds, was less than the mean of the reaction time of other students of 297.3 milliseconds. So remember, you mentioned both of the means. You need to put those numbers in there, and we need to use the comparing words. My comparing words in the sentence was less than. I will not get my free response point if I don't actually compare them. So as long as your sentence was a true sentence, like saying that one number is greater than or less than the other number, and you use context, then you are good. You're good on your points. All right. Now with variability, we could use 3 different things. We could use the range, we could use the standard deviation, and we could use the IQR. So they give you, to calculate the range, you could do the max minus the min. To calculate the IQR, you could do Q3 minus Q1. Or we could be lazy and correct and just use the standard deviation that's already calculated for us. I'm a fan of that. Let's do it. Around a room down here, but the standard deviation of the other student reaction time of 65.9 milliseconds is greater than the standard deviation of the varsity athlete reaction time of 57.7 milliseconds. So see, other was 65.9 and athlete was 57.7. I said 65.9 is greater than 57.7, so I compared them, greater than. So remember, the comparing words you only need for the center and the variability. For the shape and the outlier, you just mention the shape and the outlier of both distributions. All right, great work. All right, Unit 1, Big Ideas Review. So this is everything that we've covered so far. I just want to go ahead and do a brief review. So categorical versus quantitative data. So categorical, category, quantitative, number. And remember, quantitative can even be further categorized into continuous and discrete. Remember, categorical data goes with P, quantitative data goes with mu. All right, two-way frequency tables and relative frequencies. So that's categorical data. Remember, we keep categorical data and two-way frequency tables. You need to know the difference between frequency and relative frequency. Frequency is just count, and relative frequency is percentage or proportion, right? So count, and this is proportion or percentage. Remember, proportion is just a decimal, percentage is a percentage. Proportion is out of 1, percentage is out of 100. All right, well, there are 3 different frequencies that we learned about. Joint, marginal, and conditional. The formula for joint was the intersection over the grand total. Marginal is the category total over the grand total. And conditional is the intersection over the condition total. My fingers do not want to write what I want to write. Condition total. All right, remember when you're given a relative frequency table or a relative frequency bar chart, you have to be careful about what assumptions you make. We cannot compare different categories of relative frequencies unless we have the sample size. So if we're given a relative frequency chart, we can only make assumptions within each bar. We cannot compare different bars. All right, and then describing and comparing quantitative data. So remember, two-way frequency tables and relative frequencies is categorical data. Describing and comparing all these distributions is quantitative data. All right, so describing versus comparing, they stand for the same thing, right? The S stands for shape. The O stands for outliers. All right, the C stands for measures of center. And remember, we have to compare the measures of center. And then V stands for variability. And we have to compare the measures of variability by using words like greater than, less than, approximately the same. All right. All right, the types of graphs that we've learned about so far. We've learned about histograms, dot plots, stem and leaf plots, box plots. Box plot is box and whisker. Have I missed anything? Histograms, dot plots, stem and leaf plots, box plots. I don't think so, but tell me if I have. All right. Out of all of these, there are, let's see, dot plots and stem and leaf plots give us the underlying data. We know the exact data points going into the distribution. Histograms and box plots we cannot see. With box plots, we have the 5-number summary. So we know the min, the max, the Q1, the Q3, and the median, but that's all we know from a box plot. And from histogram, we know intervals of data. So we can give ranges for everything. We can give a range of numbers that could be the median. We could give a range of numbers that could be the range. So this dot plots and stem plots give us the most information. We have the underlying data there. The histograms and box plots kind of just give us summary. All right, our shapes. Symmetric, uniform, skewed right, skewed left. All right, our outlier test, our hot and our lot. So lot is our low outlier test, and that's going to be your Q1 minus 1.5 times the IQR. Your high outlier test is going to be the Q3 plus 1.5 times the IQR. All right, and then measures of center and measures of variability or spread. So the measures of center that we talked about are the mean and the median. Remember, the mean is the average, and the median is the middle number. All right. If we have a distribution, oops, that's skewed right, and we have a distribution that's skewed left. All right. All right, in a distribution that's skewed right, is my mean going to be greater than or less than the median? All right, I hope you said greater than, because my mean goes the direction of the skew. It's more affected by the skew. So mean would be greater than the median in this situation. And the reverse is true here. My mean would be dragged in the direction of the skew, which would be the lower values on the left side. So remember that mean is more susceptible to skewness and outliers. Remember, when we're finding the median in an even sample size, so I'm going to call that an even N. It's two numbers that we have to average. If we have an odd N, we're just going to have one number that's the median. An even N, we got to divide it by 2 and take those two numbers. So for example, if our even N was 100, if I had a sample size of 100, my median would be between the 50th and the 51st number. If I had an odd N, like 11, I know that this number, the 6th number, is going to be right in the middle. I would have 5 numbers below the 6th number and 5 numbers above the 6th number. All right, our measures of variability and spread, we had talked about 3 of them. Standard deviation, which we'll talk a lot about in the future. Range, which is your max minus your min. And then your IQR, which gives you the middle 50% of the data. So that's your Q3 minus your Q1. Which one is more susceptible to outliers and skewness? Which one between the two, if I have outliers and skewness, which one's going to be crazier, the range or the IQR? I hope you said the range. The IQR would be more reliable if we had outliers and skewness in our data set. All right, that's it. Let me know what questions you have.